Ladies and gentlemen, welcome back to our voyage of discovery into the profoundest enigmas of the cosmos and the human psyche. In the vast and eerily silent expanse of the universe, where the light from distant stars takes billions of years to reach our retinas, humanity emerges as a creature of profound contradictions. We are as insignificant as specks of dust, yet our thirst for knowledge spans as wide as space itself. As we gaze upwards at the night sky, confronting the eternal quietude of galaxies, a question echoes through the consciousness of every civilization. Why must we depart from the secure cradle of Earth? And more deeply, what is the essence of the reality in which we exist? Today, we shall not merely discuss spacecraft or lunar mineral deposits. Instead, we shall delve into the fundamental fabric of space-time, revealing that the conquest of space and the comprehension of time are but two facets of the same coin in humanity's desperate endeavor to uncover the meaning of existence. Let us commence with our most ancient companion, the Moon. What is the true significance of humanity's yearning to return to and master this silvery satellite? I wonder whether you share these reflections, observing as the world's mightiest nations pour their resources into a renewed space race. Why the Moon? And why now? From primordial times, the Moon has hung suspended in the heavens like a mysterious beacon, its cratered surface interspersed with regions of light and shadow that have sparked endless flights of human imagination. Yet beyond its poetic allure, the Moon conceals keys to our survival in the future, and the rationale for this desire can be encapsulated in three principal pillars: energy, science, and gateway.
First and most urgently, it addresses the insatiable thirst for energy that defines human civilization. The rate at which Earth consumes its resources is accelerating at an alarming pace, propelling us towards an existential crisis. Traditional fossil fuel sources are not only depleting day by day, but exact a prohibitive toll on the environment, imperiling the fragile atmosphere of our blue planet. Against this backdrop, the Moon presents itself as an immense, untapped treasury. The cold regolith dust blanketing its surface harbors a priceless gift from the solar wind: helium-3. This isotope represents the holy grail of nuclear physics, an ideal fuel for clean, safe, and highly efficient fusion reactions. On Earth, helium-3 is exceedingly rare, amounting to scarcely 500 kilograms scattered within deep natural gas deposits, rendering extraction economically unviable. In contrast, the Moon, lacking a protective magnetic field and atmosphere, has endured billions of years of solar wind bombardment, accumulating an estimated reserve exceeding 1 million tons. Recent analyses from NASA suggest figures between 1 and 3 million tons. Envision the scale of this energy potential. Successfully extracting and transporting merely 100 tons of helium-3 back to Earth could satisfy global energy demands for an entire year. A full million tons might illuminate our civilization for tens of thousands of years. Mastering this technology would revolutionize global geopolitics and economics, terminating the era of oil and coal, eradicating resource-driven conflicts, and inaugurating an age of perpetual clean energy. Moreover, lunar rocks contain ilmenite ore, from which oxygen can be extracted to sustain life, and titanium metal forged for spacecraft hulls, transforming the Moon into a self-sufficient industrial outpost. Recent developments, such as the initiatives by companies like Black Moon Energy Corporation, underscore this potential. Their planned robotic missions aim to map helium-3 distributions with unprecedented precision, paving the way for commercial fusion fuel supply chains by the late 2020s. The second rationale is one of intellectual pursuit and foresight. The Moon serves as a grand laboratory bestowed by nature. On Earth, our astronomical observations are obscured by a dense atmosphere and disrupted by myriad artificial radio waves. The Moon, particularly its far side, offers absolute radio silence and an unobstructed view into the cosmic depths. With gravity merely 1/6 that of Earth, it provides an ideal setting for physical and biological experiments impossible at home. We could construct colossal telescopes to scrutinize the most ancient celestial bodies, investigate gravitational waves, and unravel the origins of the solar system. The lunar surface,
untouched by wind or water erosion, preserves pristine material records from the universe's infancy, a petrified chronicle awaiting our interpretation. Furthermore, the low-gravity environment is essential for studying life's adaptations, from plant growth patterns to microbial transformations, laying groundwork for long-term human habitation beyond Earth. Recent discoveries, such as those from NASA's Lunar Reconnaissance Orbiter, have revealed water ice deposits more extensive than previously imagined, with estimates exceeding 600 billion kilograms at the poles, potentially increased by 10 to 20% through newly identified micro-cold traps. These findings enhance the Moon's viability as a scientific hub, enabling in situ resource utilization for sustained research. The third pillar positions the Moon as a launch pad, an indispensable transit station for our aspirations to reach the stars. Launching spacecraft directly from Earth to Mars or Jupiter demands enormous fuel merely to escape our planet's deep gravitational well. The Moon's weaker gravity permits departures at significantly reduced energy costs. We could establish orbital stations around the Moon, where vessels are assembled, maintained, refueled, and primed for extended voyages into deep space. Notably, at the lunar poles, in craters where sunlight never penetrates, scientists believe perpetual ice deposits exist. Recent studies confirm these as viable sources of water ice, with innovative detection methods using cosmic rays probing for buried reserves. Water serves not only for hydration, but through electrolysis yields hydrogen and oxygen, rocket propellant. Exploiting these resources on-site minimizes dependence on Earth supplies, evolving the Moon into a bustling cosmic harbor from which exploratory ships set sail to seek new homes for humanity. This is why superpowers such as China and the United States are targeting permanent lunar presence before 2030. NASA's Artemis II mission, slated for launch in early 2026, will send astronauts around the Moon, while China's Chang'e 7, also scheduled for 2026, will explore the South Pole for water ice and resources. These endeavors extend beyond flag planting. They forge the foundations of a multi-planetary civilization. Nevertheless, ladies and gentlemen, when we speak of traversing space, we cannot evade another enigmatic variable that accompanies it: time. When you behold the Moon, you witness its past from 1.3 seconds ago. The Sun appears as it was 8 minutes prior, and distant stars reveal histories billions of years old. Movement through space is inherently an interaction with time. But what is time's essence? Have you ever sensed time slipping through your fingers? Awaken, for modern physicists hold a truth that might make you question your very existence. Time, as we perceive it, does not truly exist. Each second, each minute you experience, the flow from past to future, is a grand illusion, a biological mechanism crafted by the brain to order events. As physicists probe the universe's deepest code, they uncover a chilling revelation. The variable termed time was never inscribed in the fundamental laws from the outset. What does this imply? The supper you consumed yesterday, the instant you hear these words now, and your funeral 80 years hence, all occur simultaneously in the universe's dispassionate gaze. Your birth, your first innocent love, and your final breath unfold right at this moment, like paintings arrayed side by side in a vast gallery. Your consciousness resembles a tiny ant crawling along that gallery's corridor, viewing one frame at a time, thus mistaking it for a temporal flow. More unsettling still is that in core physical equations, from Newtonian mechanics to relativity, nearly everything exhibits time reversal symmetry. The universe cares not for cause and effect as we conceive them. So why do you recall yesterday but never glimpse tomorrow? The response resides in entropy's rise, the universe's escalating disorder, yet your memories collude in this illusion. Today, we shall strip away the universe's disguise upon your mind, confronting a hypothesis. Time may be merely a smokescreen orchestrated by death. To grasp this audacious conclusion, we must retrace history. Over 3 centuries ago, Isaac Newton constructed a cosmic model where time was absolute, a straight river flowing unyieldingly and unalterably. This paradigm dominated science until 1905, when Albert Einstein, a 26-year-old patent clerk, shattered that worldview. Einstein demonstrated that time is not constant. It is malleable, stretching or contracting based on your velocity. The faster you move, the slower time passes. This is no abstract theory, but the operational reality behind your smartphone's GPS. Without accounting for time dilation on high-speed satellites, your mapped location would err by kilometers daily. Yet Einstein's most terrifying gift was not time's elasticity, but the block universe concept. He fused space and time into a four-dimensional entity, space-time. In this model, the entire universe resembles a colossal amber block, wherein past, present, and future pre-exist, frozen, and immutable. Imagine a long loaf of bread, each slice a cosmic moment. You believe you advance from slice to slice, but the loaf was baked long ago. Recent elaborations, such as those in loop quantum gravity and string theory, reinforce this. Space-time emerges from quantum entanglement, where particles' connections weave the fabric of reality itself. Permit me to offer a renowned thought experiment on the paradox of simultaneity, one that exposes reality's fragility. Suppose an extraterrestrial resides in a galaxy 10 billion light-years distant. If both you and it remain stationary, your presence coincide. But should the alien pedal away from Earth, even slowly, that motion tilts its time axis relative to yours. Across such immense distance, this minor tilt yields centuries of temporal discrepancy. Its now might intersect Earth's past, the Qin dynasty or Roman Empire. Conversely, if it cycles towards Earth, its time axis leans forward, aligning its now with Earth's year 3000. This proves your past, the Qin era, and future, year 3000, exist concurrently at diverse space-time coordinates. They neither vanish into oblivion nor await formation. They persist, awaiting, like map locations you have yet to visit or have passed. This inference yields profound philosophical despair, fatalism. If your future already exists for another observer, it is predetermined. You imagine freely choosing to continue this discourse or cease it, but that choice resided in the amber from 13.8 billion years ago. You merely glide along an invisible rail, unable to derail. The sensation of free will is an illusion of consciousness, ignorant of the script. This disquiet intensifies as physicists merge quantum mechanics with relativity. The Wheeler-DeWitt equation, deemed the universe's equation, omits time entirely. At the most fundamental level, the universe is static. Why then do we perceive change? Enter the second law of thermodynamics. The universe trends from order to chaos. A shattered cup does not reassemble. Hot water does not segregate into hot and cold. Time's arrow is entropy's arrow. Our brains, biological machines, record low entropy states, past, but cannot access high entropy ones, future. We resemble backward walkers, seeing only what has transpired, blind to what approaches. Recent research, including ultraviolet analyses of the Wheeler-DeWitt equation in Harava-Lifshitz gravity, suggests that quantum gravity modifications suppress certain singularity resolutions, further entrenching this timeless view. Yet, before succumbing to fatalism's void, quantum mechanics offers a slender portal. The uncertainty principle in quantum entanglement reveals that, at microscales, the universe is not wholly deterministic. Randomness is real. This slays Laplace's demon, the hypothesis that knowing every particle's position predicts the future. The many worlds interpretation posits the block universe not as singular, but as myriad layers. Each quantum event branches the universe. In one branch, you halt this reading. In another, you persist. All possibilities actualize in multidimensional space. Your consciousness merely navigates one of countless paths. Recent developments, such as debates sparked by Google's Willow quantum chip in 2024, lend credence to this. Computations exceeding our universe's age suggest parallel realities. Quantum entanglement, linking particles across vast distances instantaneously, implies space-time emerges from these connections, blurring space and time's boundaries. And finally, return to death, humanity's greatest dread. If the block universe model holds, supported by Einstein's four-dimensional space-time manifold, our perception of time errs. We envision time as a river, sweeping past into nothingness, future unborn. Yet modern physics paints a static, eternal tableau. Picture your life as a completed film reel. As the projector reaches the final scene, do earlier frames vanish? No. The real endures intact. The child you in the past, the adult you now, the elder you in the future, all coexist eternally at distinct space-time coordinates. When Einstein lost his dear friend Michele Besso, he wrote, "For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. Those you love, departed, do not dissolve into void. They live on, laughing, breathing, at their occupied temporal coordinates, locked forever in those moments, like insects in exquisite amber. We, propelled forward by entropy's inexorable flow, cannot commune with them, turning pages we cannot revisit. But our incapacity to access the past does not annihilate it. What we term farewell is merely our consciousness advancing to the next page. They remain on prior ones. The cosmic book is ever whole, no page lost." Ladies and gentlemen, our odyssey to the moon or Mars transcends physical expansion. It is how we learn to view the universe from novel vantage points, appreciating our position's minuteness and wonder. We are finite beings striving to fathom the infinite. We harvest helium-3 to sustain life, but ponder time to seek its meaning. Perhaps time is not the thief that steals all, but the guardian, preserving every moment eternally in reality's crystal lattice. Thank you for investing your precious time, that most illusory yet exquisite asset, in contemplating these mysteries with me. I trust that, at any space-time coordinate, we shall perpetuate our quest for truth. Farewell for now, and I anticipate reuniting in future voyages of thought. Ladies and gentlemen, that blindness to the future, the sense of helplessness before time's opaque veil, marks the inception of a perceptual revolution, compelling us to relinquish classical mechanics' arrogance and enter quantum mechanics' bizarre, paradox-laden sanctuary. If Isaac Newton and Pierre-Simon Laplace envisioned a universe operating like a grand clockwork where every cog meshes predictably and the future follows inexorably from the past, the 20th century hurled a boulder into that serene lake. Before you descend into fatalism's despair, where free will dissolves as mirage, behold the narrow aperture unveiled by Werner Heisenberg and Erwin Schrödinger. At matter's deepest strata, where everyday macroscale laws crumble, we encounter a seismic truth. The universe, at its core, rests not on certainty, but on probability and pure randomness. The uncertainty principle is no mere measurement limit imposed by human tools. It inheres in nature. We can never simultaneously know a particle's position and momentum. This is not merely a physical equation, but a philosophical manifesto slaying Laplace's demon, the fictional entity that, knowing every atom's placement, foresees the future. If even a lone electron lacks a definite future until environmental interaction, how can an entire universe's fate, or a human life's, be scripted immutably? Quantum entanglement propels us deeper into reality's labyrinth. Two particles, separated by billions of light years, may share an existential state, responding instantaneously despite light speed limits. This intimates that space, our divider of distances, may be illusory, and at a profounder level, all cosmic entities interconnect in a vast invisible web. From this emerges Hugh Everett III's many worlds interpretation, a haunting yet hopeful explication. Envision the universe not as a solitary line, but a colossal tree perpetually sprouting branches. Each quantum event, decision, reality's blink, forges divergences. In probability's multidimensional space, every possibility materializes. In this branch, you sit absorbed, pondering existence. In another, a variant, you elects to extinguish the screen, veering onto destiny's alternate path. All versions, all scripts, coexist parallel, layered in creation's silent symphony. Our consciousness, that fragile and precious light, drifts perhaps on one of infinite currents, experiencing a singular slice of the grand totality. And once we embrace reality's complexity, we must confront the paramount query, humanity's primal fear, haunting from antiquity: death. If Einstein's block universe, or four-dimensional space-time manifold, holds true, our time perception fundamentally errs. We conceive time as a river, eroding past into oblivion, future unformed. Yet contemporary physics suggests a more serene, eternal image. Imagine your life and the universe's history as a completed film reel. As the film projects onto the screen, characters move, age, narratives unfold. But the reel itself alters not. The opening scene of birth vanishes not when the projector reaches the end.
It endures, pristine, at its specific real position. In the block universe, past, present, future coexist. The innocent child you, the contemplative adult you, the elder closing eyes, all live, existing perpetually at their unique space-time coordinates. When Albert Einstein lost his confidant Michel Besso, he penned words now canonical in scientific philosophy. For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. Those dear to you, gone, dissolve not into smoke. They are erased not from the universe's tome. They persist, smiling, speaking, breathing, loving at their temporal loci, locked eternally in happiest instants and sorrowful ones, like creatures preserved in space-time's flawless amber. We observers, thrust onward by entropy's irresistible current, grieve our inability to converse, to reverse pages, but our access impotence means not past's destruction.
What we dub eternal parting is merely consciousness compelled to turn the next page. They linger on preceding ones, eternal and unchanged. The cosmic volume is ever complete, no page torn, faded, or lost. Each moment you inhabit now, here, shall never perish. It becomes an eternal brick in reality's four-dimensional edifice. Ladies and gentlemen, comprehending time's grandeur and mystery imbues humanity's stellar outreach with deeper import than mere resource or habitat quests. As we propel spacecraft to the moon for helium-3 extraction or envision Martian ecological domes, we transcend technological leaps. It is a spiritual pilgrimage of finite beings touching the infinite. We abandon Earth's cradle not to flee, but to gain fresh perspective. From deep space, beholding our pale blue dot birthplace, we grasp our placement's profundity. We are awakened stardust, self-reflecting. We are the universe's self-awareness. Our decoding of physical laws, from subatomic to spiral galaxies, is deciphering creation's tongue. We harness stellar energy to preserve biological life, but contemplate time and death to seek its significance. Ultimately, perhaps we realize time is no cruel foe robbing youth and memories. In its truest essence, time is the grand custodian. It preserves every touch, kiss, tear, smile as eternal artworks in the universe's museum. Nothing truly vanishes. All merely shifts state and position in space-time's lattice. Before concluding this contemplative journey, I invite you to pause and heed the silence enveloping you. Within that silence echoes the Big Bang's reverberation, quantum field's oscillations, and all that was and shall be's eternal presence. We are minuscule, yet not meaningless. We are observers, chroniclers, bearing consciousness's flame to illumine this chill cosmos. Thank you for devoting your precious time, that illusory yet beautiful, scarce essence of a lifetime, to musing these enigmas alongside me. I hope at any space-time coordinate, on any multiverse branch, we perpetuate our truth quest, cherishing each present moment as the eternity we hold. Farewell for now, and I await reunion in forthcoming contemplative odysseys.